Anyway, before the presentation comes in, good evening, ladies and gentlemen. I'm here to talk about smart energy. Well, at Reliance Mumbai, we are dealing with a smart city. Smart not in terms that it is fully smart as in terms of smart cities, but it is one of those financial capitals where a lot of people, as Mr. Reggie was saying, below the poverty line or the slum dwellers are there. So I'll just take you through my presentation, but I would like to say that my endeavor in this presentation is to see that how we can use digital world to, transform the network, make them intelligent, and transform our services to the customer so that they do not have to come out from their homes or the offices to get the services and queue up at the distribution utilities office. Next. Achha, you can do this. So I'll give you an overview first, and then I will take you this to our journey to smart utility and the challenges. See, we, as Reliance Infrastructure, we are into energy business in the domain of generation, transmission, and distribution. In infrastructure, we know that we are in roads and metros and now heavily into defense. We have an EPC which has been doing our services for setting out the power plants. As Reliance Energy, which I represent, we have a power plant at Dahanu, which is 500 megawatt power plant. And there's another power plant at Butibori of 600 megawatt, which supplies to Mumbai. We have a transmission network in Mumbai, which is managed at 3000 MVA. And we are one of the largest private distribution utility, which supplies 24/7 uninterrupted power to about 30 lakh network consumers. So we do supply 24/7, but I feel that with digital connectivity, it's getting better. So just to take you through the chain of the generation at 16.5 converted to the transmission at EHV 220 with 3000 MVA capacity, and then stepping down to 33 kV at 70 receiving station at 33/11 and in Mumbai, and having 6,000 substations is the entire chain of GTD. Now, if I look at this word intelligence, we all have an intelligence. Well, machines also have an intelligence, and today we talk on M2M, that is machine to machine or peer-to-peer communication. Well, if you take it in simple words, I've stated here, it's generator, switchyard, FGD and all intelligent. It is very simple, There are a lot of transducers in this system, and there are a lot of analog signals like pressure, temperature, volt, etc. And they are converted into a digital signal, right? That's the simple stuff. That means when you're converting an analog to a digital, you are imparting intelligence to it. So whether it is our turbine, whether it's a generator, whether it's a switchyard, whether it's the FGD, which shows us the SOx, NOx, or the other levels of the pollutants, everything is in our Dahanu plant monitored through a remote control center, right? And we are proud to say that in Dahanu, which is 500 megawatt, our PLF has gone as high as 105%. Now, here the entire plant is under CCTV surveillance. So what I was saying, the decisions whether the turbine, the input to that turbine has to be more or less, the steam flow should be more or less, etc., is actually governed from a long time with a machine-to-machine communication. So today we talk on a world of IoT, that is Internet of Things, which is nothing different from this. This is a higher version maybe, but it is as simple as that whenever you have sensors or a software or an electronics embedded in an object, each can communicate to the another object, and in turn can come to you for where you can take a centralized decision. Now you come to the distribution part. If you talk on network and retail, on the network part, we have a unique ring main system in Mumbai, and because of that, the switch gears which are motorized are remotely controlled through the SCADA. So whenever there is a failure or an outage at a part, it is immediately restored through the remote SCADA system. So that is a kind of which I term it as digital, but going forward I'll tell you what we are going to do it to make it more IoT friendly. Now we have theft in Mumbai in terms of slums. We have put up technical solutions. We have put theft of pillars. We have put this thing, though our loss level is at 9% approximately, we are targeting to go to 8% and then maybe 7 or 7.5. So there what we do, we put in theft of pillars. Wherever if somebody opens the pillar, there is a tripping circuit which trips the switchgear and the entire area goes dark. And the people who are not stealing, they actually approach those people who are doing that mischief, and it is a society which comes into action or play, and then the theft goes down. So similarly, we have meter cabins wherever if the meters, whatever meters are put, somebody draws more, there is a trip circuit built into the meter cabin, it trips the meter cabin. So like that, we have fall passage indicators and the others, as you see there, which is all monitored through a SCADA. We have a GIS system, and we have an ERP. The GIS gives a location of all our assets. We do our network planning through a GIS. We do our outage management through GIS. So GIS is the basic platform which now controls. Now talking on digital comfort, as I said, I stated that lives made easier. That means we have a social media presence in Twitter, LinkedIn, Facebook, etc. Now, we don't stop at that. We have developed a mobile app, which I'll show, and we have put a WhatsApp number also, because we feel that these are medium by which people are getting connect. And suppose you want to make an online application, you can do it from the comfort of your home. You can just go into the mobile app, or you can go to our website, you can click it, you can submit your forms, and you can do anything and everything on that from the comfort of your homes. You can make the payment, you can do a change of name, you can do an extension of load, whatever. You need not come out of your home. That's what we say like that, and we have given a WhatsApp number here. First time we are trying to do it. So this is a mobile app, just to give you a small demo of it. So that's what we call life made easier at the fingertips from your home. Now, coming to the other side of data acquisition on a hardware level, we have done a project where we have put up a canopy, a gateway. The gateways we had put up about 21 gateways and put up about nodes, 2, 2, 3, 4 nodes. We had made a RF communication, and we have tested that pilot, and we are going in for a whole entire 400 square kilometers. We are planning to implement 500 gateways, and to start with 32,000 nodes, and then maybe go on to maybe up to 500 units if the smart meters are there. So if you look at the communication levels from the RF, the nodes communicate through RF, and then it goes to the cloud through optical fiber where our receiving stations are connected, or through a cellular 4G. So it's a hybrid. If one fails, you have the other. That means you have an optical fiber or a cellular or a PLCC or a Wi-Fi. Now these, from this cloud, it goes to the servers, to our business analytics. And as we all know, there's a huge outburst of data. A smart meter can send about 60 pieces of data. Well, that's converted into a permutation combination through a business, through a big data analytics. And it gives you, let's say, 6 deliverable informations right to the field. That means, suppose there's a power outage, it goes to the workman on the field and says, you need to restore this. He has a PDA on hand, and he does it. Whether it's a theft, then it says, yes, there is a theft, will you please go and check that. If there is an overdue or outstanding, goes beyond a limit, he can attend that. So basically, this becomes, and then it comes, it's to a two-way communication. Two-way communication, it goes back to that. So you get, this is a two-way communication, which we have said on the acquisition, transport, and the analysis level. Now I'll show you that we have done on how do we monitor. We always say private distribution utilities do better, but the point is the accountability, ownership, or the responsibilities are driven by motivations. We have a reward system. We have a quarterly beat the best. We even reward a fuseman or a meter reader who has done his good job. He comes with his family and he enjoys it in front of family. We built in a performance dashboard. We built in our performance management systems through the KRAs and KPIs, and that is how it is done, and it is done now on a weekly basis. So this is a kind of a dashboard which we have developed. This dashboard is live. I'm just showing a static picture which gives you what is the demand. This is internal. We are now launching it on the external. The energy purchase, the new connections given online, the average billing rate, the reliability, how many solar rooftop panels have been installed, the net meterings have been done. And it goes zone-wise. There are 5 zones. In each zone, what is the reliability, what is the collection efficiency there, what are the new connections added, and the distribution loss. This goes onto the computer live through the IPs of those decision makers, the business operation heads and all that, and they see it daily and monitor it and see that the performance is on track. By this, as I said, that we have been able to do a predictive analysis, and as I was saying, when you have a transformer or a cable or a switchgear saying that a sensor embedded into it, that I am not healthy, then means it says that you come and do my prescriptive maintenance. If you take it to the a normal level, they say that today we have a shirt, I think Arrow, which has a cuffling which is smart. So a person who is traveling and his clothes say that you are suffering a heart attack, maybe, that means what happens, it sends a signal to an ambulance, and ambulance comes and goes by the side of his car. He says, sir, you are not well, please come in. You know, that's what's going to happen, and it's not fiction. I think it's virtual reality, and that's what's happening. I remember about 15 years back, my boss used to tell me that when you get up in the morning for going to a tour, you're always in a hurry. So while you move in the bed, the sensor senses, then your coffee machines and toasters, etc., bigger on, and you get out in a jiffy, and the refrigerator orders his rations and all that. Well, that's reality, not only into a consumer world, but also into industrial Internet of Things. That's what I wanted to put forward to the audience. In the smart grid maturity model, in the green, which you have said is being done. In the blue, like self-healing grid, we are on the way to do it. Predictive maintenance, as I was talking about. Advanced sensors, putting sensors on them. And the AMI rollout is suggested. Obviously, it depends on the approval by the regulator. So this is the final slide. The smart utility, or the smart as a distribution utility, or the challenges are that yes, the policy has been made by the government that you put up smart meters up to 500 units, and thereafter maybe up to 200 units, but the cost has to be approved by the regulator to take it forward. There should be a business case for the distribution utilities to see that what is the ROI, what is the benefit the consumers are deriving out of it. For example, in a home automation on a high end, it can conserve its devices which are today smart and reduce, and if the regulator puts a time of use tariff, then he can use that time of use tariff, and without being intrusive, those devices can control and maybe flatten the peak. So that's customer transformation. Obviously, with so much burst of data, there would be a cybersecurity problem which needs to be addressed. We always feel if there's an adversity, there is an opportunity. So our job is to convert the adversity to opportunities, and that's how we should succeed. And with that, I end my presentation, and thank you for a patient hearing.